Related to carbon capture, we need a relatively concentrated stream of gas coming from the chimneys of the biogenic industries, and this accounts for a range between 10 to 20% carbon dioxide in the total gas. The gas stream that comes from the industry chimneys is a mix between carbon dioxide, it can contain oxygen and other impurities such as sulfur oxides or nitrogen oxides. And these impurities can account for some small percentage of the mass of the gas. However, carbon dioxide accounts for the highest concentration of the gases that are present in the mix. In general, the highest concentration of carbon dioxide in the gas makes the process more efficient. However, there is a threshold that above 20% of carbon dioxide might not result in a highest removal due to the mass transfer limitations and other limitations of the carbon capture process. The minimum concentration that we believe that is fundamental to make this process efficient is about 10%. At the end of the carbon capture process, we have a highly pure stream that contains almost only carbon dioxide above 95%. And this will be the input for the CO2 utilization processes. But what about the utilization of carbon dioxide? Is there a minimum CO2 concentration that is necessary to achieve efficiency?
For us, of course, it's also good to have, let's say, a high concentration of CO2, but we are not sure if there is a minimum threshold that we need in CO2. But of course, the higher the concentration, the higher also the efficiency in terms of electron efficiency, what we call coulombic or Faradic efficiency, as well as carbon capture. When we use a certain CO2 stream, of course, we want to make as much use of the carbon in the form of carbon dioxide that is therein and turn it into a valuable product, mainly formic acid within VIVALDI. This is a good question. Of course, when we think about chemical process or pure electrochemical processes, there you often want to have high purity. But when we think about the combination of an electrochemical abiotic process with a biological process, like we do in VIVALDI, there of course is a little bit different, because some impurities that we see there, the nitrogen compounds but also sulfur compounds, actually they can act as a kind of nutrient for the microorganisms that not only will use then the nitrogen compound and the sulfur compound add-on feed, but especially use, of course, the formic acid that we produce from carbon dioxide via abiotic electrochemical reaction.